Hi everyone, welcome back to my Z80 computer series. So if you've been following along, you'll know I'm attempting to make my own Z80 retro computer, an 8-bit computer using the infamous Z80 processor from Zilog. So where have we got to with this project? We've got the CPU running, clock and reset circuits. We've done some input. We've done a little bit of output on the 7-segment displays. I've started to build the keyboard. I'm going to show you a bit more of the keyboard in the next video. But I've kind of got to the point where I'm thinking we really need a video display. I'm going to struggle to move forward with the project without a video display. So the last video I attempted to start looking at the VGA timing. Things didn't work out quite as well as I'd hoped, and they're still not, to be honest, and I'm not really sure what direction I'm going in. I don't think I've done a very good job of explaining any of the video. I didn't want to do too much talking, so I'm gonna stop talking now. I'm going to start showing you what I'm doing here. So we had the horizontal timing sorted out. We had some horizontal sort of bars on the screen last time, different colors, and the way that worked, again, I probably didn't explain it very well, but on this board here I've got the vertical counts as well as the horizontal counts. The vertical ones are on this side and the horizontal counts are on the other side. Got them broken out so that we can tap into them, and I took signals off of here to feed into the red, green and blue colors. So that's what's generating those bars that we saw on the screen last time. Now the modification I've made here is two of them, and I believe it's the green and the red, are still going straight into the buffer through the resistors, and then they come back out here and get fed into the VGA. But the blue one, I'm just using that as a source of signal that I can play with to try and generate some pixels moving across the screen as the scan line goes across horizontally, because I wanted to see if I could control the individual pixels. Now what's happening with that is it's going into the OR gate, and that's getting combined with this signal here, this green wire here, which is coming from a shift register over here. So we'll come back to the shift register in a minute to see. This is the pixels getting fed in and combined with the blue signal, so that in theory, we should get some blue pixels on the screen, but if we look at the colors, you'll see they're not blue. I'm slightly confused myself what I've done with the colors, but I think it is logical. It's just there's a lot of confusion going on. So how am I getting the pixels into this shift register? Well, for the moment, just to experiment, I've got some dip switches here. One side of the dip switches are set to plus 5 volts. The other side of the dip switches, a little difficult to see. I know this whole thing is really difficult to see, but there is a little bank of resistors in here. And they essentially go down to ground. So there's a load of pull down resistors there on the dip switches. So the signals are either pulled down to ground through the resistor, or they're pulled straight up to the 5 volt, depending on where I position the switch. So those signals then come off there on these yellow wires and go into the shift register. And then the shift register is a 165, I believe. I can't read it, but I'm pretty sure it's a 165, 74HC165, which should be a parallel to serial shift register. So we're feeding the data into here as parallel, and then we're shifting it out bit by bit out the green cable here, combining it with the blue and displaying it on the screen. Now, there's a load of problems. So there's a couple of extra chips on here. In fact, there's a lot of extra chips now because I keep adding more and more chips to try and solve problems. My theory is on every 8 horizontal clock counts, I want to load 8 bits of data into the shift register, and then on the next sort of 8 clocks it will clock them out, and then we'll come back to the next 8, we'll load another 8 into the shift register, and we keep clocking them out. So I need a signal, I need to feed the load signal on the shift register every 8 horizontal clock counts. Now, I initially thought, well, I can just tap off the 3rd bit here, off this wire here, and that would give me a signal on, I've just pulled the wire off, that's great, isn't it? That will give me a signal on every 8 horizontal clock counts. Problem that I had with that was it held the load line low for the whole 8, for about, I think, 4 of the 8 cycles it holds it low, and then high for 4 counts and then low for 4 counts, which is not what we want. We want a nice short pulse to load the data into the shift register, and we kind of need things to happen instantaneously, and they don't happen instantaneously, and that's why there are some issues. So I actually I should probably try and leave some links to the videos. I looked at a video to see how we could generate a short pulse. So when we do get this signal coming from the horizontal counts, I'm feeding that into firstly some inverters, and then through a NAND gate, and this sort of combination of circuit gives me a very short pulse. I won't go into the technicalities of it, just sort of trust me for now that these 2 chips are converting our signal that we're getting from the horizontal counts, putting them through this this circuit here, and it gives us a short pulse out. And if I show you on the oscilloscope, that is the blue line at the bottom, and you should be able to see we get a pretty short pulse, which causes the shift register to load the 8 bits. And then the purple line we've got here is the output of the shift register, so we get a low, high, low, high, low, high, low, high. And I think if I count that again, that's 1, 2, 3, 4, 5, 6, 7, 8 pixels alternating on and off. So that is pretty good, is pretty much what we want, but there are two main problems, which we'll see in a minute. Just trying to think. There is a little bit more explanation if I want to cover everything on here. Now, one problem is we don't really want to load the pixels on count 8. We want to load them on count 0. We want them straight away to start drawing on the screen. So we kind of want this pulse here, we want this to be on count 0, and then we want it to be on count 8, and then I think 16 and so on. So we want it to start from 0. We don't really want it to start from 8 or 7. I think it actually was loading in at. So to try and solve that, what I sort of worked out I really need is, we've got another 74HC30 in here, which I was using on the main board. I just happened to have spares, so I threw that in there. And what I can do is I can look at the first 3 bits over here. Sorry, I realise I'm pointing and I'm not showing you the camera. The first 3 horizontal bits on the shift register of the horizontal counts. I can look at the first 3 bits, feed them into the AND gate, and I can figure out when I'm on that sort of count 0. So the first 3 bits come into there, go through this NAND. Sorry, it's a 8 input NAND gate, and I'm just sort of tying the extra bits low. I'm sort of looking at it now, wondering whether I've actually ditched that part of the circuit, because I'm telling you absolute rubbish. That is no longer an 8 input NAND gate. Okay, I see. The 8 input NAND gate is actually up here, because I needed to invert the signals because I wanted to look at the zeros. So because I'm not breaking out the inverted versions of the signals, those signals do exist on this circuit, but I didn't break them out on the header. So I took out the non-inverted ones, threw them through an inverter, and then they go over here into the 8 input NAND gate. I'm only actually using 3 inputs, but I just happen to have a spare 8 input NAND gate and I don't think I have a 3 input version, so I just threw that on there. That gives me a signal out, but I think I'm just kind of looking at things. I think I've ditched that, because normally the signal comes out up the top here, and then I was using that to feed the shift register's load, but I've ditched it. It's sort of solved one problem and caused another, and I'm kind of going around in circles with it. So let's just check. I believe the load signal's actually coming off this here. It's just, I've just gone back to loading it off the third bit, which you'll see as we look at the screen. I've kind of gone back to having the problem of not loading the pixels at the right time. Let's have a look at the screen. What I'm going to do is, you're looking at the screen, I'm going to flip some of the bits on this. I can't really show you both at the same time. Now, I don't know what that's going to look like on your screen, but I'm particularly looking at this area up the top here, because we should really see, if everything was working, we should see the very first pixel right in the top left corner should change as I flip bit 0 on this circuit here. And if I do that, you'll see it's not. It's flipping a bit that's kind of in here, which is actually pixel, if we call that 0, 1, 2, 3, 4, it's flipping bit 4 rather than bit 0. And there is actually another problem which you can see manifesting, that it didn't entirely disappear. Now, I should explain that my pixels on the screen, the black bars, that's actually when the pixels turned off, they go black, and when we turn it on, they go blue. So that's on, so it's blue, and I turn it off and it goes black. Yeah, they're stretched, aren't they? They're not square. Now, the reason for that is, with the circuit board I built, I have a horizontal resolution across the screen of 200 pixels, and I've painstakingly counted them all, and there are exactly 200 pixels across that screen. They're just quite fat because we're at a very low resolution. 200 pixels is, we would normally have 800 pixels across the screen, but because I'm using a 10 megahertz clock instead of a 40 megahertz clock, we only get 200 pixels across the screen. I'm intending to increase that later, but I wanted to get this working first and then try and increase things. So it is, I mean, I don't know how well you can see that, but it is pretty good actually. I am getting the pixels sort of on and off as they should be. It's just I'm not controlling the correct ones when I flip the bits. Now, if I flip all of the bits, you'll gradually see the pixels are disappearing, and it's just repeating the signal on every line. So now I've turned them all, essentially I've turned them all on, so it should be completely blue across the top. And it isn't. We've got, I don't know, again, yeah, you can see that, can't you? There's little slithers of blackness still left in there. So it's not quite right. The timing's not quite correct. There is also very slight banding, which is more visible. Again, I don't know what's showing up on the camera, but more visible on the white. I can see it a bit in the cyan. In the magenta, it's pretty much gone, and the blue, it's gone. But the lighter colours, there's some sort of shadows on the banding there. So again, I think the timing's probably dropping the voltage a little bit, and the colours going a little bit more towards the black. I'm not so bothered about that, and I think some of it is caused by loose wires on the breadboard. The main problem here is the fact that we've got these sort of black bits that aren't quite drawn in, which we really would like to solve. If I show you the timings on the oscilloscope, I can kind of demonstrate what that problem is. Now, the yellow line here is the first horizontal count, the count on the horizontal counts, like bit 0 off of the horizontal counter. So this is kind of how we're clocking the pixels. And the purple line that we're seeing is the actual pixel data that we're pushing out, whether the pixels should be turned on and off. So the yellow line is our timing, and the purple line is what we're actually outputting. Now, if I move the yellow line down over top of the purple line, you can kind of see, hopefully, we're a little bit off. We've got some gap between the purple and the yellow. Now, what's strange is it looks like we're actually a little bit early in the clock cycle, although I do wonder if maybe we're like a whole clock cycle late or something, and we're not quite meeting the times. I'm just going to invert the pixels. In fact, I've got to reset them because I changed everything. Let's run it, and it's a little easier to see. You can kind of see as I'm turning on bit 0, you can sort of see this is a better way of showing you the reason why we're getting a little bit of black on the screen. If I turn them all essentially on, so all the signals are gradually going high, you can actually see we should not have these dips in here. Again, if I move in the yellow, I'll just stop that to give us a clearer signal. And then if I move the yellow down, you can kind of see, if I flip the first bit, oh, I'm not running, am I? Let me run that again. So it is manipulating the first bit, at least the first bit whilst we've loaded it. It's not the first bit on the screen because the blue pulse is in the wrong position. It is flipping that bit, but I think the issue is it's the width of this pulse, or at least it's probably like just some propagation delay inside the shift register. When I tell it to load, it needs a few nanoseconds to actually load, and during that time we've dropped low. I think there's something else going on there, because I'm kind of wondering, well, why is it low at the start? Because the last pixel was actually high, so why is it low? Now I think the reason it's low, if I just move channel 1 out of the way again, if I just got to get back to an alternating pattern of pixels, which I'm making a mess of. Okay, I think what's happening is we're actually shifting the pixels out, and I think it kind of feels like this purple line's a little early for some reason. I think we've clocked them all out, and we've still got a little bit time left to go before we get to the next pixel. And I think because it shifted all the bits out of the shift register, if it was allowed to continue without another load, it would just shift out a load of zeros. Because I think it shifts things out to the right, and I think it shifts extra pixels in from the left, and because there's nothing coming in from the left, we end up running out of pixel data, and then it drops down to a 0 just before. And if I move channel 3 down, that's happening. If I get that up a little bit, that's happening just before we reload the data. So we're kind of running out of pixel data before we tell it to load the next lot. So it's kind of the position of this purple signal that's a problem. So I'm not sure where to go with it. I don't know how to solve that problem, but I'm in some ways not too worried about that right now, because we won't be loading data from dip switches. We'll actually be loading data from memory. So I think probably the next place to go with this circuit would be to actually get a static ROM,
and I'll probably just borrow the one out of the Z80 computer because it's just the only one I have, so I'll just borrow it out of there. Load some pixel data onto it, and then just try and build up some logic circuits that can decode the addressing. It'll need to be looking at the horizontal and vertical counts. I'll need some additional logic to do this, and then it will need to transform those counts into memory addresses that we can load memory from. And then I think once we've done that, we're probably going to find we've got more problems, because it takes time to do that address decoding and load the data from memory. Now I think eventually we could solve all of this. I think we could solve the timing constraints, because although we probably can't load 1 pixel of data on every clock count, we're probably just not fast enough to do that. But I want to load 8 pixels at a time, so one single memory read will bring me 8 pixels, which means I don't need to do another memory read for another 8 counts, which is quite a bit of time. So if there is some way I could prefetch the data so that it was available for us, I think I could keep up with the memory reads. So there's a lot of theory and a lot of explanation, and probably very little progress right now. So I think in light of that, I'm going to pause on the VGA for the moment, and like I said, the next video will go back to the keyboard. Okay, I hope that was a small update for you to let you know where I am. I'm going to leave this here, and I'll see you in the next one.